Today, we will be talking about conversion, how we actually converge our platform from architecture perspective with the help of GraphQL technology. And we will also talk about our challenges during this journey and how did we actually found a solution and implemented it. So let me introduce myself. My name is Satish Chitnis. I'm the principal architect at Paramount, and I'm responsible for infrastructure team as well as API and core services. So I have a bunch of architects working with me. And let me describe the conversion problem. What is conversion means in the architecture world? So we'll talk about that. I'll talk about some of the operational challenges we had during this journey. And also, I'll talk about some of the technical challenges. Giacomo?
Yeah, so hi, my name is Giacomo. I'm a software architect in Paramount. I'm based in Milan, Italy. So I'm also an open source enthusiast. So if you go to that GitHub account, you will see some of my open source projects. And today I will talk about how GraphQL could help to solve the problem that Satish will describe, and then what GraphQL tools and frameworks we use it to address all those challenges, and then what we learned during this journey. And then at the end, we will have a Q&A session with me and Satish. And yeah.
Thank you. So before I start, how many people guys know EPG means? EPG is like when you turn on any streaming service, you will see a list of channels with the timeline so that you can see what is the upcoming programs that are coming up, right? And this is a common problem across streaming. So you go to Paramount Plus, you go to PlutoTV, or if you're watching Netflix, everyone has that same problem. So that's the reason this is the service we picked for conversion, which is a little bit not that complex. At the same time, it addresses one of our business domain. So who we are. We have an architecture team at Paramount. These are dedicated individuals, group of people who wants to design, optimize, and evolutionize to make the platform, this streaming platform architecture, scalable. Our mission is to enable the world-class multi-brand streaming platform for free and paid, linear and on-demand entertainment by combining the shared knowledge of technology experiences of the Paramount streaming organization. So we have close to 3,000 people, and the architecture team is helping to make the standards and the technology work across the world. As I said, we have a multiple engineering team. Not that we build each individual team, but we actually acquire some of the companies. As a result of that, we have a multiple engineering teams through the merger process, right, historically. And the nature of the business is same, as I said, the streaming business. So there is always, in the back-end side, the APIs are duplicate across the organization. And that's obviously a productivity loss. So we wanted to avoid that duplication, and that is one of the goal of the conversion, and consolidate those APIs seamlessly, and obviously improve the productivity of engineering team. And this is where the GraphQL actually helped. And we did it in a systematic way, which is very important. We can't just take the APIs, which are running across multiple organizations, and combine it. We have to go in a systematic way, and we can talk about that during this journey. Another challenge we have in Paramount is because we have a multiple engineering team, each team has a primary language that they write a code in. And we also wanted to ensure that when we use GraphQL, we can support those languages as a first-class citizen so that the team feel closer. They don't have to learn new language just for the GraphQL implementation. Another challenges we have is we wanted to make sure the APIs that we are building are consistent. We have multiple cloud, as each organization has the one organization using GCP, another one using AWS. We wanted to ensure that our solution can scale, can deployable across multiple cloud, and also can be deployed in multiple regions, so that if one region goes down, there is a resiliency in terms of deployment. And then another thing to talk about, when we employ this solution, there is a set of technology that comes along. So this picture shows you how much complexity is involved when we talk about building something first class and scalable. You have your API gateway, you have design standards, different programming languages such as Rust as a first class citizen, so that we actually can support this organization. Also have to have observability so that we can actually monitor the APIs and perform. So what are the operational challenges we encounter, right? As I said, we have a multiple engineering organization. They are involved in day-to-day basis on high priority projects. And you all know when you talk about technical projects, the business priority always goes down, right? You don't have that priority. You don't get those priorities. So we had to work cleverly so that we don't take away those resources from the project. At the same time, we achieve this goal of conversion. As an organization, multiple organizations have different Jira boards, different program managers, different product managers, different leadership team. So we had to have that collaboration across all these teams. At the same time, the architecture team was enthusiastic to make this solution work. Because of how collaboratively we worked, we could deliver this EPG solution on time. Another important aspect is how do you build trust within 3,000 engineers? It's important, right? You can't go and speak to each and every one. So we have to have some vehicle. So we use something called community of practice. Community of practice is a group of individuals coming together and talking about on a project, on a set of subjects. They'll talk about different aspect of that project, and then spread the knowledge across the board so that we can actually build consensus within thousands of engineers. So actually that process helped. Another challenge we had was each engineering organization has different way of working, right? So when you talk about breaking that barrier, we have to be very, very smart in terms of how do we make those individual teams work together. So we also use what I call Jeff Bezos' 2-pizza rule. So when we started this project, we selected few individuals from each team so that the team is not very big enough that you cannot feed 2 pizzas at the same time. That's what Jeff Bezos said. And that's exactly worked very well. If we had used a complex service with the hundreds of engineers, you cannot get them on the same page. It will be hard to deliver anything. And as I said, the footprint is extremely tiny, so we could actually able to deliver and converge this microservice successfully into production. What are the technical challenges? I talked about different languages. We use Node.js. One organization uses Node.js, another one uses Java, another uses Golang. But we wanted to make sure our solution in GraphQL can be implemented by all these 3 languages. So we did the research and we provided the solution. And we'll talk about that. As I said, we talked about we have a different infrastructure. We have one is GCP, another AWS. So we wanted to make sure our solution is deployable across multiple cloud. And another challenge we had is the common business domain. This is very, very important. Example, when you talk about EPG, one organization call it a channel as an object, another one call as a listing. So now we have to have a build consensus so that we can merge the data model and we can call it a one entity across all 3 organizations. So that's very important. as you're building these projects. I talked about different skill set. We provide a solution for all 3 languages so that the team feel comfortable. Strong performance requirement. This is very, very important for streaming world. Our API performance is extremely, latency has to be less than 200 milliseconds. That means the response has to go back. And we are talking about the scalability of 900 billion call on an API. This is the EPG API getting 900 billion call a month. Can you imagine that? That's kind of a volume we are talking about. Performance has to be there. Scalability has to be there. And we ensure that the performance is optimal. Another challenge we had was about, this is a traditional REST API world. You have large API responses. That means we have designed the solution for many, many devices. We have a Roku and many more. So sometimes the APIs that are responses coming back are some for mobile, some for desktop. And that becomes a large responses. And some of the low power devices cannot handle that. And this is where GraphQL was a savior. GraphQL, you can only ask what you get, and that helps those devices. And also for mobile devices, there is a low bandwidth area. You want to make sure that you can watch the TV. This also helps tremendously, because now you can optimize all that using the GraphQL technology. With that, I'll hand it over to Giacomo. Thank you.
Thank you, Satish. OK, so we have a problem. We have many challenges. So in the architectural team, we had the task of finding a solution. So when we designed the solution, we preferred a top-down approach to solve this convergence task for different reasons. One of the reasons is because, again, we have to ensure the business continuity, and by adopting a top-down approach could help to address this challenge. And then we also needed an approach which is phased. So we cannot implement a big bang solution, so a migration to GraphQL in a big bang way, but we need to phase this migration. And then we thought to GraphQL to address this problem, because GraphQL enabled this top-down phased approach. And then, thanks to the adoption of the GraphQL Federated Architecture, we can avoid to introduce a layer which represents a single point of failure. But I will talk about this more in the next slide. So in this picture is represented the starting EPG architecture. This is a simplified view of the architecture. So again, we have different organizations in Paramount. Each organization has different teams, and each team is responsible for different front ends, different EPG services, different backends, different data stores. So our goal is to find a solution to start to converge all those layers in just one single common architecture. Again, we designed a phased approach. So this is the first phase of this approach. So first of all, what we did is the introduction of a new layer, which is the GraphQL Federated layer. So the introduction of this GraphQL layer has different advantages for Paramount. So first of all, what is important here to say is that thanks to GraphQL, we can ensure the backward compatibility with the existing technologies in Paramount. So again, we have to introduce something without breaking the existing architecture. And all our services are mostly based on REST APIs, gRPC services. So we needed something that is compatible with these technologies, and GraphQL is actually compatible, because we can actually connect the GraphQL layer to the existing APIs. And then another feature, another advantage of adopting GraphQL is that it allows a backward compatibility with legacy devices. So in Paramount, we have to support a lot of devices, smart TVs, mobile devices, and all our customers have a lot of legacy devices. So we needed a technology that allows us to support these backward, these legacy devices. And thanks to the advantage of GraphQL to ask from the client for what actually you need, we can ensure the compatibility in terms of performances with all those legacy devices. And then the introduction of a GraphQL Federated Architecture, which means having different subgraphs that are federated in just one single subgraph, supergraph, allowed us to address the technical challenge of supporting different tech stacks. In this way, we have some subgraphs for each organization built with different technologies. So subgraphs built with Golang, some subgraphs built with Node.js, and some subgraphs built with Java. And all those subgraphs are then federated in just one single supergraph. And then if you, so as described by Satish, we had also the operational challenge of having different teams that works in different ways in each organization. So they are, let's say, separated. And the introduction of this common layer helped us to address also this challenge. In fact, with this common layer, teams started to work closer. We adopted the monorepo approach to enforce this collaboration between teams. So the entire GraphQL layer is basically pushed on a monorepo. So on a monorepo with different technologies. And again, this helped us to start to converge not only architectures, but also teams. In the second phase, we had another goal, as said by Satish. So we have common business domains across the different organizations, but with different data models. So in order to converge architectures, we need to ensure also to converge these data models, because common data models allows also the implementation of common front ends. And this is also our goal. So this is the second phase of the convergence, which is the convergence of the front ends. So by converging the data models, this means also having simpler subgraphs, simpler schemas, and because you have common data, and this helped also to simplify the front-end implementation, because once you have common data between the different organizations, then you can also, in GraphQL, implement common queries, which represent a simplification on the front-end layers. And this will allow the second convergence goal, which is the convergence of the front ends. In the third phase of this journey, so once we have the data models normalized between the different organizations, so they share the same data model, they have a common GraphQL layer, they have common front ends, then we no more need the legacy EPG services. For legacy EPG services, I mean the existing REST APIs. So we can start to move all those services to merge these services into the GraphQL subgraphs. And this means removing the legacy EPG services layer and converge everything into the GraphQL layer. And this represents also an improvement in terms of performance, because the GraphQL layer can be simplified. So the subgraphs can be simplified. So this means that the query plan that the gateway has to process will be simpler. And this means better performance on client side. OK, this is the final phase of our journey. So we converged the front end. We have now common data models. The legacy EPG services have been merged and converged into the GraphQL layer. So this means that we can start the convergence goal also in the backends. For the backends here, we mean all the systems that are behind the EPG APIs. So all the systems that the different organizations uses to store EPG data and so on. So again, the convergence of the EPG services into just one single common GraphQL layer allowed us to start to work on the convergence of the different backends. OK, what are the tools, GraphQL tools and frameworks that we explored and adopted in order to work on this project? So first of all, for the client implementation, we adopted the Apollo client library, which has a lot of nice features like declarative data fetching and request and response caching, which is very important for us to address the performance requirements. As shared by Satish, performance are very important for us. So having those features on client side helped us to improve the performance perceived by the user. Then the server approaches. So the approaches that we adopted for the implementation of the subgraphs. So in GraphQL, you have the code-first and schema-first approach. We adopted both the approaches. For example, we had to adopt the schema-first approach due to some limitations of the GraphQL Java libraries. There are not so many Java GraphQL libraries that support the code-first approach. But both the approaches are very good. But I will give you more details in the next slide. For the subgraphs implementation, again, we have different tech stack based on Golang, Node.js, and Java. So we used gcoolgen for the Golang subgraph implementation. We used Nest.js for the Node.js subgraph. And then we used Java for Spring for the Java subgraph. And all these three frameworks, this is a strong requirement for us, are compatible with the Apollo Federation because we adopted the Apollo Federation for the GraphQL Federated layer. API management and routing. So for this, so we adopted the WunderGraph Cosmo router gateway for the routing part, and then the entire WunderGraph platform for the full life cycle API management. WunderGraph is an open source framework that has a lot of features like schema registry, composition checks, analytics, metrics, tracing, and so on. We deployed this platform on-premise. So, and that for us is a strong requirement. And then at the end, we adopted the data loader pattern. Our EPG APIs are affected by the N+1 problem. And we tried and we actually did implement the data loader pattern to address this issue. And we found a lot of improvements in terms of performance by adopting this pattern, which decreased the number of requests to our backends. What we learned from this journey? Well, first of all, GraphQL is, for us, was not only a technology, but is a strategic enabler. So GraphQL has a lot of advantages for front-end development, but again, it is really useful also as a strategic tool, in our case, to address the convergence goal. And again, as I said before, the fact that GraphQL is compatible with existing technologies like REST, it's an advantage, because in this way it's quite easy to introduce GraphQL on an existing architecture. Then it's important to clarify the role of GraphQL in the architecture. So GraphQL is quite new as a technology. So some engineers might think that GraphQL is a replacement for all the backends in the architecture, but this is not true, because GraphQL is closer to the front end. So in our case, it helped us to remove the different backends for front ends instead of replacing all our backends. And this is why in the previous slides there were still the backends layer. And then we had also, it's important also to clarify why GraphQL over other option. So again, the same goal, you can address the same problem, the same goal also with other technologies like REST or gRPC. So some engineers could say, okay, why we have to learn a new technology if we can do the same thing with also other existing technologies? So it's important to clarify why. In our case, the reason is that, yeah, it's true that other existing technologies can do this, can address the same problem, but with GraphQL, we achieved the same goal, but in a simpler way. So we removed a lot of boilerplate code, a lot of complex logic from all the different backends for front ends. So we just introduced a new layer, and we did the same thing with a more simple logic. GraphQL requires a mindset shift. So in GraphQL, you have to think in terms of graphs. So this represents a mindset shift comparing to how usually you design APIs when working with, for example, REST. So it's important when you have to introduce GraphQL into existing architecture, it's important to find some trade-offs to simplify this mindset shift. In our case, the code-first approach represented a good way to simplify this shift, because with the code-first approach, we basically reused all the existing data models to generate the schema. So the existing teams didn't have to learn a new SDL, a new language, to implement GraphQL. For sure, they had to understand how the code-first approach works, but in our case, it has been quite simpler comparing to the schema-first approach. But this doesn't mean that the code-first is better than the schema-first and vice versa. So those two approaches are valid approaches, and the adoption of the code-first or the schema-first depends on the use case. So the schema-first could be better if if you have the possibility to, for example, to dedicate a team to the schema management, because the management of all those schemas, it could become quite hard since they start to evolve. So it's important to dedicate teams for the management of these schemas. On the other side, as I said before, with the code-first approach could be more useful if you have to introduce GraphQL into an existing architecture or into existing teams that do not have a huge knowledge about GraphQL. So in this case, the code-first could be better. And then new performance metrics. Again, performance are really important for Paramount. And by adopting GraphQL, we had the possibility to work with new metrics to improve the performance. Those metrics are field-level metrics. So this means that you can check, you can answer by checking those metrics. Basically, you can answer to questions like, OK, what field of my schema are used more? And by answering to those questions, you can actually simplify your schemas. And you can also guide the content strategy and, as a consequence, simplify, improve the different data models. So these represent for us a very important metrics. And that's it. Thank you. And
Thank you.
Yeah, so initially the GraphQL federated layer was just an additional layer that just talked with the existing REST APIs. So it was an addition.
Okay. So then were the EPG services, they were providing your backend for front-end responses, so how the screen should look and all that stuff?
Exactly.
So is your federated gateway, did you change that over to being like a more data model approach, or is your federated schema serving DFF data?
Yeah, we have different subgraphs. We had different subgraphs, one for each EPG service. So initially, because again, we had different data models. So basically, we had different schemas, subgraph schema, that at the end are federated in just one single supergraph. This means that the supergraph had the data representation of all the three organizations. And then we started to work on the data model convergence to simplify the schema in just one single schema. So remove.
The initial approach, you ended up with like basically 3 separate.
Yeah. So you want to?
Yeah. I think so we actually evaluated Apollo, and one of the challenge we had was Apollo licensing term, right? I think its enterprise is extremely expensive, and right now we are going through a lot of budget cuts and optimization. So that's the reason we wanted to adopt something which is open source and fully compatible, getting observability. All those metrics are important. At the same time, we cannot invest in the cost right now. That's the reason we went with the WunderGraph.
Yeah, and I would also to add that initially we implemented all the subgraphs by using just Apollo libraries, and then we had this possibility to migrate just the router and the server implementation to WunderGraph, since WunderGraph supports the Apollo Federation, which is, so for us it has been quite easy to migrate from Apollo to WunderGraph.
So we are about to start using the subscription. Subscription is actually on the target. We haven't implemented. This is the first microservice. Will be more microservices taking advantage. And absolutely, subscription is a very powerful capability that GraphQL provides. And it solves many problems. And I agree. We will obviously share those experiences. But right now, we are in the phase of implementing that.
Yeah.
What made you choose Apollo over other client libraries like Relay, which are open source?
Sorry, could you repeat that?
Yeah.
What made you choose Apollo over other client libraries like Relay?
Yeah, repeat the question.
Yeah,
I think what she's asking is, why did we choose Apollo client library or other libraries were open source? Is that correct? Yep.
Yeah, so we started with Apollo. We did some tests with also the WunderGraph client library, but we decided to proceed with Apollo because it provides a compatibility across different, it supports a lot of frameworks. So basically, for us, it was just better to adopt Apollo because basically we had, in this way, the possibility to adopt the same library across different organizations. Because initially, we talked about server tech stack, but also on client side, we have different tech stack. So with Apollo, we had the possibility to adopt the same implementation across different organizations, also in terms of front-end implementation.
Yeah, one thing I will add is React compatibility. I think we found that the React framework that we use, it's actually more compatible with Apollo. They have tested it, and it's well tested APIs. So I think that's the reason we went with Apollo as well. Any other question? Okay. Thank you so much. Thank you.